This is a test review for Math 147. I think that's Texas A&M University, Exam 1. And I'm going to show how to answer these questions for anyone who's preparing for this exam. All right, the first question says, which of the following functions corresponds with the graph in Figure 1? Here's Figure 1. Now notice, 0 is not over here, x0. x0 is over here. So if you remember, log function, you don't have to know much about it. Log function does not go into negative x values. So these two are out. This graph has negative x values. Log of a negative value is undefined. And so is it y equals 2x? Well, 2 raised to the x, 2 to the 1 is 2. I'll just make a little table. When x is 1, it's 2. When x is 2, it's 4. When x is 3, it's 8. Notice how it's increasing. This one increases. This function isn't increasing, it's decreasing. C is out. This is decreasing. When what you're raising to the power is less than 1, then it's a decreasing exponential function. So this one has to be D, just because, well, again, it doesn't cross. It crosses into the negative values of x. That gets rid of the logs. And it's decreasing, not increasing. 2 to the x increases. So the answer has to be D. Here's the next one. Use a logarithmic transformation to find a linear relationship between appropriate transformations of x and y if y equals 2 times 7 to the 4x. Well, use a logarithmic transformation. So I have a 7 here, so I could use log base 7, but that's not really common. I guess I'll show it with log base 7, and then I'll show it with log base 10. So if I want to do log base 7, I can do log, not ln, I want log. Log base 7 of y equals log base 7 of 2 times 7 to the 4x power. Now remember, log AB, if I'm multiplying two things together in the log, that's log A plus log B. So I can split that up. I can say, I'll keep writing it over here, y equals log base 7 of 2 times log base 7 of 7. Oh man, not enough room to write it. Let me write it over here. Y equals log base 7 of 2 plus log base 7 of 7 to the 4x. Now remember, if I have log a to the b power, I can take the power and put it in front. So I'm going to rewrite this as y equals, I'm going to put the log base 7 of 2 over here, and then put this one first. 4x times log base 7 of 7. What is log base 7 of 7? Well, that's just 1. So I get y equals 4x plus log base 7 of 2. So that would be one way to answer this. Another way would be with like log to the 10th. So I can do log base 10 rather. Log base 10 of y equals log base 10 of 2 times 7 to the 4x. It's supposed to be a 4. Why can't I get a 4 there? Wait a minute. 4x. Okay, now nothing's going to go away this time because I'm log base 10 and I don't have any 10s in there. So I can rewrite this again as log, this is log base 10 of y, equals log base 10 of, I'm going to put the 7 to the 4x first, because the x component should be first, plus log base 10 of 2. And then this 7, log base 7 to the 4x, I can put the 4x out front, I get log of y, log base 10 of y, equals 4x log 7 plus log 2. And if I want to, I could put the x at the end, so I could say this is 4 times log base 10 of 7, 4 log base 10 of 7, x, because I put the x at the end, that's why I put these parentheses, so it's clear I'm not taking, x isn't inside the log, plus log of 2. So that would also be a correct answer. Log of y equals 4 log 7 times x plus log of 2. And then another valid answer was y equals 4x plus log base 7 of 2. So the next question, number 3, given a semi-log plot in figure 2, find a functional relationship between x and y. Well, here's the semi-log plot, figure 2. I think that's figure 2. And a semi-log relationship is going to look like this. Log, and these are tens to power, so it's log base 10 of y, equals mx plus b. Now, some people write b, some people write log of b here because b is the y-intercept, and you're going to take a log again, but you can just write b. Well, let me check this out. When x is 0, y is 10 to the minus 1. So when x is 0, y is the log of 10 to the minus 1. Well, what's the log base 10 of 10 to the minus 1? Well, you can put the minus 1 in front. Log base 10 of 10 is 1. Negative 1 times 1 is negative 1. So it's negative 1. So it's 0, negative 1. And then over here, so now I know my y-intercept is negative 1. See, that's why a lot of times people will put log of b. But anyway, so this is, I now know it's log y equals mx, I don't know what the m is, minus 1. I've got that part. Okay, what's this other point? This point is 4, comma, and then it's 10 to the 1. Well, the log of 10 to the first power is just 1, so 4, 1. So I've got 2 points, and I can find the slope. That's supposed to be a 4. This I'll call point 2, this I'll call point 1. The slope, the slope equals y2 minus y1 over x2 minus x1, which equals y2 is 1 minus y1 is negative 1, divided by x2 is 4 minus 0 equals 1 minus negative 1 is 1 plus 1 is 2, 4 minus 0 is 4, 2/4 equals 1/2. All right, so now I know my m is 1/2. Let me get some more room over here, I guess, to the right of this thing. So I know my slope is 1/2, so now I know my equation is log of y equals 1/2 x minus 1. Now technically this is log of base 10, so you could do the fish hook, 10 to the 1/2 x minus 1 equals y, or if you don't want to do that, or don't want to remember all that, get rid of that 10, you just raise 10 to the power of both sides. So 10 to the log base 10 of y, log base 10 and 10 cancel out, so this is just y equals 10 to the 1/2 x minus 1. Remember this exponent rule for when you have same bases to different exponents. A to the b plus c equals a to the b times a to the c. Well, so in other words, same base to one power plus another power, so 1/2 x plus negative 1 or minus 1 is 10 to the 1/2 x times 10 to the minus first. And again, I'll put the 10 to the minus first in front because I want the x at the end of the term. Well, 10 to the minus 1 is 1 over 10. Y equals, I can put 1 over 10. 10 to the 1/2 is a square root of 10. And remember, a to the bc power equals a to the b raised to the c. So 1/10, 10 to the 1/2 is square root of 10. And then I could say raised to the x power. So I could write it like that. Y equals 1 over 10 times square root of 10 to the x power. So that's number 3. Number 4 is a double log plot. A double log plot, I can solve like this. There's a hard way, I think a harder way, but I can use this easier way. Y equals c times x to the m. So I can use, I'll have 2 points. Y2 divided by y1 equals cx2 to the m divided by cx1 to the m. I was almost going to put xm. I don't know why. So now I have to find out what these values are. And there's a way to read this kind of a plot. This is a log plot. So this is 10 to the second. This is 1 times 10 to the second. This is 2 times 10 to the second, or 200. This is 3 times 10 to the second. This is 4 times 10 to the second, or 400. You can write it either way. So this is 5 times 10 to the 6, 7, 8, 9 times 10 to the second, and then the next one would be 10 times 10 to the second, or 10 to the third. See, it goes up to the next power. So I have a point here, 10 to the 0 is 1. So this point is 1, 400. I'm going to use that to find this in a second. I'm going to use all that to find the slope. And then here, this is 10 to the fourth. 1 times 10 to the fourth, 2 times 10 to the fourth, 3 times 10 to the fourth, 4 times 10 to the fourth. In other words, 40,000. I can use either one of those. And this point for the x is 10 to the first, which is 10. So this point is 10, comma, you can put 40,000 or 4 times 10 to the fourth, whichever one you would like. Okay, so I have 1 400, and I'll write it down here, 10. I'll write it the other way this time, 10 40,000. Doesn't matter which way you write it. So now I put this, where did I write all that y stuff? Wait a minute, what happened to my y's? Oh, I put it over here. So I'm going to call this point 2, and I'm going to call this point 1. Y2, which is 40,000, or 4 times 10 to the fourth, divided by y1, which is 4 times 10 to the second. I want to make sure they're both in the same format, equals, and if both of these are 2, look what happens with this fraction. The c's are going to cancel, so I don't have to worry about that for now. And since both are to the m power, I can just do x2 over x1, the whole thing to the m power. So this equals x2, which is 10, divided by x1, which is 1, and then the whole thing is to the m power. All right, the 4's cancel. 10 to the fourth divided by 10 to the second. Subtract the exponents. 4 minus 2 is 2. This is 10 to the second equals 10 over 1, which is 10 to the m power. What does m equal? M equals 2. So now I know that this is y equals c. I don't know what the c is. X squared. I know it's squared. So now I can take one of these points, 1 400, or 1 comma 4 times 10 to the second, or I can use 10 comma 40,000, or 10 comma 4 times 10 to the fourth, and plug it in for x and y. I'm going to use this one because it's simpler. So I'm going to put 4 times 10 to the second equals, I just say 400 because that's what y is, 400, equals c times x, 1 squared. Well, 1 squared is, and this should be, 1 squared is 1, so 400 equals c. So c is 400, and now I've got my whole answer. Let me get more room here. My whole answer is y equals, c is 400, or 4 times 10 to the second, whichever you'd like to write, 400x squared. So remember, it starts with this formula. Y equals c, x to the m, and then you have y2 equals cx 2 to the m divided by y1 equals cx1 to the m. The c's cancel, and the m you can actually just write as 1 exponent. So that's how you can do a log-log. This is called a log-log or a double log plot. All right, let me look at number 5. Might as well. I think I've only got, do I have 5a? Do I have any more? Okay, so there's going to be one limit. I'll do the rest of the limits in another video, but might as well do this one. 5a, it says compute each of the following limits. X squared minus 4 over x minus 2, limit as x goes to 2. Well, if I substitute 2 in there, 2 squared is 4, 4 minus 4 is 0. 2 minus 2 is 0. I have an indeterminate form because I have 0 in the denominator. So I can't do that, but I can factor. Remember, a squared minus b squared, and 4 is just 2 squared, equal to a plus b times a minus b. So if you plug in the limit value, in this case 2, x approaches 2, and you get an indeterminate form, try factoring. So I'm going to factor. And this is x squared minus 4. 4 is 2 squared, so this is x squared minus 2 squared. It's x plus 2 times x minus 2 divided by x minus 2. And see, the x minus 2 terms cancel. Now I can plug that 2 in. 2 plus 2 equals 4. So the limit as x approaches 2 of x squared minus 4 over x minus 2 is 4.